Welcome to the workshop. Today we want to take a look at section 3.6, Marginal Distributions. And we're going to introduce the section by returning to the same example that we had actually looked at the beginning of section 3.5 as well. I think that marginal distributions are something that we're actually already familiar with. So hopefully this isn't anything too new, but it may be. So let's take a look at what we got. All right, so returning back to the previous section, we created this table, which actually came from example 2.8.1, all the way back in section 8 of chapter 2. So what we were given in that example way back in chapter 2 was the probability that Larry, Mo, or Curly would fill an order at a warehouse that fills and ships orders. I'm trying to remember what they call that. Anyway, doesn't matter. So we've got the probabilities that Larry, Mo, or Curly fills an order, and what we're given is the probability that they make an order given that they're the one that fills it. So that's a conditional probability along with the probability that they are the one that fills it, gives the probability that Larry makes a mistake, Larry fills it, and he makes a mistake. So this is the probability of two events occurring: yes, a mistake, and Larry filled the order. This is the probability that Larry filled the order that we were given. And when we look at these, right, this number plus that number gives us that one, because if Larry fills it, he's either going to make a mistake or he doesn't. So those are the individual probabilities which give the total probability that Larry filled the order. So if we add up, right, in the last section we talked about the joint probability distribution, and if we add up the probabilities in each row, then that's going to give us the probability that the thing happens that designates that row. So this row is for Larry. That's the probability that Larry fills the order. So the probability that Larry fills the order is 0.25. But then we can also take a look at the column and say, all right, well, this column represents yes, and if I add up all of those, this is the probability that yes, a mistake is made. And this would be the probability that no mistake is not made by adding up all these probabilities. So in the previous section, we also gave the designations that yes was 0, no was 1, Larry was a 0, Mo was 1, Curly is 2. So that gave us distributions of variables x and y. So looking at it in terms of random variables, we're looking at the probability that random variable x, sorry, on this one that's y here, probability that random variable y is equal to 0 is 0.25, because this represents Larry filling the order. And then what's the probability that a mistake is not made? Well, in the idea of events from back in chapter 2, that would just be, okay, well, no mistake was made, or however you want to say that, and it'd be 0.9685. But here, within the context of discrete random variables, we might look at it as the probability that the random variable x takes on the value 1. Again, that's 0.9685. So we see these probabilities represent the overall column or row designation, probability of the overall column or row designation. And these probabilities being written in the bottom margin and the right margin of our table, they're given the name marginal probabilities, okay? And we'll look at them as collectively the marginal distributions, right? Marginal distribution of y and marginal distribution of x. And that's what we want to take a look at. And of course, a similar idea, this is the idea for two discrete random variables. And we'll also take a look at what it means for us to have a marginal distribution for a continuous random variable as well. All right. So in our next video, we'll take a little bit more of a look at two discrete random variables. So I will see you guys back in the workshop very soon.